Hi guys, so today we're going to be discussing Leetcode question 744, which is find smallest letter greater than target. So the question is, you are given an array of characters letters that is sorted in non-decreasing order and a character target. There are at least two different characters and letters. So what do we have to do? Return the smallest character and letters that is lexicographically greater than target, that means alphabetically. If such a character does not exist, return the first character and letters. So our main idea here is to, let's say, if we are given a target C, we have to locate C or the element which is just less than C lexicographically or alphabetically and return the one greater than that. So in this case we have C here, right? So we're supposed to return F because it's just greater than that. So this would be our answer. Let's say if we had, instead of C, if we had B here. So since in this array B is just less than C, so what is the next greater element? F. So again the output would be, in that case, would be F. So having got this cleared, how can we do this? We can obviously use a linear search array where we can search the element which is either equal to target or just less than that by just doing an O of n iteration over the letters array and returning wherever we find this index, returning the element just next to that. But can we optimize this? We are given the information that the array is sorted in a non-decreasing order. So can we utilize this information to perform better in any manner? Since it is sorted in a non-decreasing manner, so we can probably use binary search to compute this. How? The idea is very simple. We use binary search to do what? To find the element which is matching or just less than, or is it just a less than element with respect to target. So this is what we have to do. So how can we do this? So I've written the algorithm here for that. So as we, for the array, we keep iterating as long as this condition satisfied, while left is less than equal to right. So left is essentially this part in the beginning and the right is the rightmost index, which is this. Excuse me. So in this case we perform the binary search. What are the steps of the binary search? Find the middle index and then search if you have to search for the target in the left half of the array or the right half of the array. So we're going to be proceeding in the same manner. So this is essentially a binary search, but you can say a bit modified binary search. So we iterate as long as we have the left index less than equal to right index. And what do? We find the middle part. We find the middle of that part of the array and we check if the target as compared to the middle part of that, is the target in the right half or the left half. If it is, so we just move left to just ahead of the middle. So essentially what we do here is we make left equals to mid plus 1, and here what we do is we make right equals to, when we're searching in the left half, right? So that means the end in this case, the right half in this case would be mid minus 1. Since we search till mid and it's not there, it's less than that, so it must be somewhere in the range from left to mid minus 1, and in this case when we're searching in the right half, it must be somewhere in the range from mid plus 1 to the right. So that is what we do. Let's understand this algorithm via dry run, and in the end we return letters right plus 1. Why? I'll show you that in the end after a dry run, so that it becomes much clear why we're doing this. So let's say this is the array that we have. C, F, J. This is the start. Start is equals to 0. And this is the end, which is 2. This is index 0, this is index 1, and this is index 2. So in iteration 1, when we're doing the first iteration 1, what happens there? We calculate the mid, right? We calculate the middle, which is The formula for that is either you can use the binary search one or just do this start plus end minus start divided by 2. So in this case it would be basically calculate the middle from the start and add these many middle indexes. So then in this case it would be, since start is 0, 2 minus 0 divided by 2, this gives us 1. So this is our middle, and you can check the array at the middle position, which is F. So I'm just writing this as array, or you can use the actual name, letters middle, that is greater than equal to target, right? How? Because letters middle is what? F, and target is C, so it is greater than that, right? So that means we have to search in right half. So this becomes, so in this case that means end becomes, sorry, search in left half. So end becomes, or you can say start is basically left and end is basically right. So end becomes middle minus 1, mid minus 1, which is in this case 0, since 1 minus 1 is 0, right? So we immediately fall to this part where end is now this part, right? So in second iteration 2, what is the mid right now? Using the same formula, 0 plus 0 minus 0 divided by 2, this gives us 0. So letters middle as compared to target, what is letters middle? Letters middle is C, and what is target? Again it's C. So this is just equal to, right? So we have a match. So since we have a match, and after this iteration this condition satisfies, right? Because we have to then exit the loop. So once we have a match, we exit the loop and we return, what do we return? We return letters, in this case right plus 1, right? Or end plus 1. So end was 0 plus 1. So we essentially return F in this scenario. Why do we do return right plus 1? Because our aim is to output the smallest character that is greater than target. At the right index, we have found a matching character or just less than element with respect to target. So therefore, right plus 1 index must be the immediately greater character than the target. So that is why, since here we matched our element, where we matched our condition that this is the place where we have either the target or the element just less than that. So since this is a sorted array, so the next element at the next index must definitely be just greater than that, which is exactly what we want. So that is why we do letters right plus 1. This is what we return, and in this case 0 plus 1, which is nothing but the F character. So I hope you understood this, how to solve this question using the algorithm I just showed you via dry run as well. I hope you guys enjoyed the video. I'll attach the link for the GitHub repository for the code for this problem in the description below. Please feel free to check that out. Thank you for your time and have a nice day.